being done. So flow control in TCP. Flow control in TCP. In real time, even if we have studied all these flow control mechanism, let's look into in real time how exactly the flow control mechanism is being so conducted or is being so handled. Okay, so it is somehow so different. To some extent, it is different. So from the theory, what you have understood, so how the flow control is being maintained. Okay, so that's why we need to understood that. So from that perspective, so first of all, in case of TCP, where there is a need of flow control, let's try to understand. So if I look into that, so let's say this is my sender, this is my sender, this is my receiver. At the sender end, as we have already known, all the 5 layers of TCP/IP stack is present. Let's start with the application layer. This is my application layer at the sender end. Okay, so this is the application layer at the sender end, and next to it is the transport layer. Transport layer at the sender end. Similarly, so at the receiver end, the application layer and the transport layer. Transport layer. I'm not highlighting all other layers because we are not much concerned about at this point of time. Okay. So here, how by using this application layer and transport layer, how TCP is sending and receiving. So by applying this flow control mechanism, try to understood. Okay. So what the job of application layer? We have already understood the application layer job is to generate message. The sender part, let's look into the receiver part. Okay, application layer job is to generate a message. Generate a message. Okay, after generating the message, what the application layer is going to do? So the going to send it to the transport layer. Application layer going to send the data to the transport layer. But now the question is, whenever it is going to generate the data and send it to the application, sorry, transport layer, so transport layer buffers maintains a buffer. Okay, this is the buffer. That is basically the send window. So that means, so transport layer maintains a buffer, and whenever the data is coming, it has to store in the buffer first. So from the buffer, then transport layer will take this data and send to the other party. Okay, now it is going to send to the other party, other end of the transport layer. Okay, when it is received at the other end of the transport layer, other end also maintains a buffer. That is called as the receive buffer or receive window. Receive buffer or receive window. That means the receiver is going to maintain a receive window, the sender is going to maintain a send window. Okay, so and then once the data is going to receive at the transport layer of the receiver, then the data is stored in the buffer at the receive window. Okay, and now once it is stored in the receiver buffer, then when the application layer going to consume the data, try to understand this is a different concept. So data has come and stored in the buffer. Data has come and stored in the buffer. Okay, these are the data, let's say, has come from the other end or the sender end and stored in the buffer at this point of time. Now, so the buffer, now the question is, till what the data is going to be in the buffer? Till what point of time the data is going to be stored in the buffer? Okay, so can anybody think of, till what point of time the data is going to be stored in the buffer? We are not pushing the information from the server to the email, to the client or to the recipient. Rather, the recipient is going to pull the data from the mailbox of the respective server. Similarly here, remember, once the data is arriving and stored in the buffer, receive buffer of the transport layer. Okay, so transport layer does not send the data to the application layer. Rather, application layer is going to pull this information from the buffer. Application layer is going to pull this information from the buffer. So why I'm saying like this? Because whenever you are writing an application program, you are calling the RECV API. Now, if you remember, in TCP we are calling a RECV API to get the data. So from where we are getting the data? When you call RECV, we are getting the data from the buffer what is stored. Okay, let's say we say I want 100 bytes of data to read. Now already I have received 500 bytes of data at this point of time. ऑलरेडी मेरे पास 500 बाइट का डेटा रिसीव हो चुका है, कहां पर, इन द ट्रांसपोर्ट लेयर ऑफ माय ऑपरेटिंग सिस्टम. So now the receiver is asking to read only 100 bytes of data. So do you think that all the 500 bytes of data what is received at the transport layer is going to be sent to the receiver? No. Only, so whenever receiver is requesting to access the data, to get the data, so then only at that point of time, so it is going to pull from the buffer and give it to the receiver. So that's why, so remember the concept, application layer, transport layer does not push the data to the application layer. Rather, so in most of the cases, application layer pulls the data from the transport layer, that is whatever data is present in the buffer, by calling the RECV API. Okay, so whenever the user is calling the RECV API, at that point of time only, so the data is going to read from the buffer if some data is available in the receive window at the transport layer. Have you understood the concept first? So application layer generates the data, send it to the transport layer, transport layer keep the data in the buffer. Okay, so then, so go and send the data to the other end. So when other end is receiving, it is putting the data into the buffer. So it is going to put the data in the buffer unless until application layer is going to receive the data or pull the data from the buffer. So that's why, so it is not the responsibility of the transport layer to deliver the data to the application layer. Rather, it is the responsibility of the application layer to fetch the data. It sense in TCP if we understood the basic concept, how the communication happens between the sender and receiver. Okay. Now, so with respect to this, what we understood? So that means, so a send window is being maintained at the sender end and a receive window is going to be maintained at the receiver end. But who maintains that? Transport layer. Remember this concept, transport layer maintains this buffer, not the application layer. Application layer does not maintain any buffer. So it is the job of application layer to generate the message and call the send API. So call the send API to send the data. Then you don't know what is happening behind the scene. That is next job comes into picture, that is a transport layer internally, so maintains a buffer and store your data, so before sending your data to the other end. Okay, similarly, so other end of the transport layer maintains a receive buffer at its own end and receive your data, and unless until application layer consumes the data, it still so go and keep the data inside the buffer. Now, so this is, so next question, based on this, can anybody tell me, so does the sender need to maintain a receive window? Can anybody think of, is it required to maintain a receive window, so by the sender, and a send window by the receiver send window? Is it required or not? I say initially a send window is being maintained by the sender and a receive window is being maintained by the receiver. But is it required to maintain a receive window by the sender and send window by the receiver? Yes or no? Just think logically.
Yes, sir.
Some data na, receiver भी data कुछ भेज सकता है ना. So if receiver wants to send some data, how, when receiver application generates some data and send it, receiver wants to send some data. Okay, so to the, so sender happens na, he is going to respond back. So whenever he is receiving something, whenever the receiver is going to respond back the data, he is again going to generate the data na, receiver is going to generate the data. And now when he is generating the data, where he is going to keep the data? Not in the receive buffer, he has to keep the data in the send buffer. So that's why he has to maintain a send buffer as well. So ultimately what I understood, so every end maintains two buffer. Every end maintains two buffer. One buffer is called as a send buffer, one is called as a receive buffer. What is the job of send buffer? Send buffer job is to, so go and keep the data when application layer is generating some data to send to the other end. So that data is stored at the transport layer in the send buffer. So whenever the receiver is receiving the data, so at the transport layer, it is receiving and keeping the data in the receive buffer so that application layer can go and read the data. So whenever it feels to read the data from the buffer. Okay, so that's why we have to understood both the end maintains send buffer as well as receive buffer. It is not that sender only maintains send window, receiver is only maintaining receive window. So both the sender and receiver has to maintain send window as well as receive window. That is the first, another one important concept you have to understood. Another one most important concept you have to understood. So can anybody tell me, so what will, so send window size is controlled by the, so send window size is controlled by the receive window size. Receive window size. That means whatever is the receive window size of the other end, so accordingly the send window size of the sender has to be set. Send window cannot set its send window so without knowing the receive window size. So that's why a feedback mechanism has to work now. So that means so the transport layer of the receiver needs to send a feedback mechanism, needs to send a feedback. So advertising its window, that is nothing but receive window, so that flow control mechanism can be achieved or flow control can be achieved. So receiver window is always advertised so as a feedback mechanism to the transport layer of the sender, so that sender can set its send window. Then what happens? So now based on this, let's say I set so receiver window capability is 800. So now transport layer of the receiver inform me that is my capability is 800. After receiving, I set the send window to be 800. Then what is going to happen? This information must be given back to the sender, na? Okay, sender ko pata hona chahiye. So 800 bytes of data is available so that I can generate 800 bytes of data. If I go and generate more than 800 bytes of data, so then so my data is going to lost. So that's why. So again, another feedback mechanism is going to work between the transport layer of the sender and the application layer of the sender. So to inform that, so once the buffer is full, the information must be sent back to the application layer. Let's say I have a so buffer of 800 bytes. Already 800 bytes buffer is full. So should the sender so generate any data? Should it be allowed or not? Should the sender allowed to generate the data if the buffer is full? No. So how the sender is going to know? Sender does not maintain this buffer. So that's why transport layer of the sender sides must inform the application layer once the buffer is full, so that sender is not going to generate any more data, so thereby achieving the flow control. That means to achieve flow control, so what happens? A feedback mechanism from the transport layer of the receiver so going to happen between the transport layer of the sender and receiver to inform what is the receive window size. Once the receive window size is known to the sender, that is the set window size, send window size is set accordingly. So then, so when the application layer generates the data, and once the buffer is full, then a feedback mechanism has to be sent back to the sender saying that the buffer is full, please you do not generate any data, so otherwise your packet is going to lost. So this is how the flow control in TCP is going to work. But so I will make you understood so in more detail how the flow control works so through one example. So think of the SYN packet. After sending the SYN, when the ARC packet goes from the other end, in the ARC packet there is a receive window advertised. Have you remembered this concept, Jami? Have you remembered?
That class I missed, sir.
Miss means you should at least cope up with the class. You cannot tell me in the class you have missed the class. So I have always asked to ask me the recording. Otherwise, you can discuss with me. You can't tell this answer, Jami. I am not expecting from you, Jami. Okay, anybody else? So whenever I am sending a SYN packet, when the ARC packet is coming back, in the ARC packet, so there is a receive window advertised. Have you remembered that? Anyone? In the ARC packet, so a receiver window is advertised. So that's why, so this feedback mechanism, what I talked about, that happens in every ARC packet. Remember this concept. Every ARC packet coming from the receiver so to the sender as a consequence of some data has been received. So every time the ARC packet is being sent by the receiver, it is going to advertise the receive window. So that's why initially the receiver window is advertised during the connection. Let's say this is my window. Okay. So whether it is a send window, receive window, doesn't matter. So it is a window. Let's say having the sequence number like 0, 1, 2, 3, 4, 5, 6, 7 and 0, 1 repeated dot. Okay. Now let's say my window size is 7. Let's say for example, this is my window size. Okay. Now we have already known this is known as the left wall of the window. This is the left wall of the window. And this is called as the right wall of the window. This is the right wall of the window. Now try to understood. So when the left wall of the window moves towards right, try to understood. When the left wall of the window moves towards right, that operation is called closing of the window. Window closes. When the left wall of the window moves towards the right. So if I say now my left wall is on 0, so now my left wall moves to 1. So that means window is closing by position. Window closes. This is called as a window is closing. If the left wall of the window moves towards right. Now similarly, if the right wall of the window moves towards right, so this is called as a open. Window opens. Okay, there are three operations basically on a window. One is a window close. When a window is closing, if the left wall of the window moves towards the right, so that is called as a window is closing. If the right wall of the window is moving towards right, so that is called as a window is opening. And another scenario might occur, very rare, but so sometimes it occur. So if the right wall of the window moves towards left, so this is called as a shrinking of window. S-H-R-I-N, shrink. Three operations. One is called as closing of window. Closing of window, if the left wall of the window moves towards right. Okay, right now the left wall of the window is on 2. If it moves towards right and reaches at 1, so that is called as a closing of window. That means if the left wall of the window moves towards right, right. This is called as a what? Window is closing. So what is opening? If the right wall of the window is moving towards right, that is called as a window is opening. That means the right wall of the window moves towards right. So this is called a window is opening. And what is shrinking? If this is the right wall of the window, if the right wall of the window is moving towards left, पीछे जा रहा है, आगे नहीं जा रहा है, पीछे जा रहा है, so that is called as a window is shrinking. If the right wall of the window moves towards left, this is called as a window shrinking. First of all, you understood this concept. What is window closing? What is window opening? What is window shrinking? Now, with respect to this basic concept, so as far as send window is concerned, all the three operations are possible. Window can close, window can open, window can shrink. S-H-R-I-N-K, shrink. But the shrinking of window is so very rare. And also, so that it depends on the implementation. Some of the implementation does not allow to shrink the window as far as send window is concerned. But still, you have to understood, so there is a possibility a send window can shrink. But that again depends on how the respective TCP has implemented the concept. So it may allow to shrink the window, or it may not allow to shrink the window. But there is a possibility, so window can shrink. But as far as receive window is concerned, so only close operation is allowed and open operation is allowed on a receive window. So no shrinking operation is allowed as far as the receive window is concerned. So we understood that send window can close, open, shrink. Receive window can close. This is a receiver. Okay. Now let's say I send a SYN packet first. First I give the scenario, then I will tell exactly what happens. The scenario is I'm sending a SYN packet. The other end is generating a SYN plus ARC. Then finally, a ARC is being generated on behalf of it. Okay. So then after that, the sender is sending, let's say, some 200 bytes of data. Sender is sending some data that is of 200 bytes. 200 bytes of data the sender is sending, and as a result of it, it is getting an ARC. Okay, and then finally, another bunch of data is being sent from the sender. So that is, so 300 bytes of data is being sent. 300 bytes of data is being sent, and as a consequence of it, it also send an ARC. Okay, and also after this, finally one more ARC is coming. Okay, why this is coming, how it is coming, I will tell. Okay, so now this is the scenario. With respect to this scenario, let me explain the whole operation of closing and opening of a window at the sender and receiver. Okay, Now, so let's say when the scene packet is being sent, along with the scene packet, there is one important information is going in sequence number. Can anybody tell me what is the significance of the sequence number that is going with the scene packet? What is the significance of the sequence number that is going in the scene packet? First, tell me, what is the significance? And that 100 is nothing but ISN. If you remember, it is called as the ISN, initial sequence number. Okay. So what is this initial sequence number? This is the initial sequence number that sender says, so whenever I'm going to send the first packet, so towards the receiver, so a packet will be with the sequence number 100. That is called as the initial sequence number. At this point of time, there is no expectation of the receiver. Okay, because so sender has not sent anything. So what receiver can expect out of it? Nothing. Okay, so this is the initial sequence number. Then after that, so the SYN plus ARC is coming. So can anybody tell me what should be the ARC value here inside the SYN plus ARC, and along with that also a sequence number field is going to so go along with this. So what is the initial packet I'm going to send? Whenever the sender is going to send the initial packet, what should be the sequence number he is going to put? So that is nothing but the initial sequence number. That has to be informed to the receiver. Similarly, when the receiver is going to send its own fast packet so to the sender, he must so go and put a sequence number. What should be the fast packet sequence number whenever the receiver is going to send the fast packet to the sender? So that is put in the sequence number field, and that is random. That is called initial sequence number. But what I told right now, so along with this information, as you rightly pointed out, there is another important so window that is going to advertise, that is called as a receiver window. That means so along with the so acknowledgement number, sequence number, so the receiver is going to advertise an window. So that is called as a receive window. Buffer of 800 bytes. Okay, so that's why receive window should be advertised as 800. Zami, are you getting my point? So we have to inform what is the acknowledgement, what the acknowledgement number says. Acknowledgement number says that the SYN packet is received successfully. What the sequence number is telling? Sequence number is telling what is the initial sequence number of the packet I am going to send from my end to the sender. So then what is the receive window? Now receive window says what is my capability, what is the maximum size of the data I can receive at this moment from the sender. So these three information has to be sent along with this SYN plus ARC packet. Jami, are you getting my point?
Yes, sir. Yes, sir. So
Now,
this receive window was the
1001. Please try to understand this concept. So this kind of question might be asked in the examination. A scenario will be given, and you have to you will be asked to draw the diagram. This is called as a timeline diagram. This diagram is sometimes referred as a timeline diagram. You'll be asked to draw the timeline diagram for the respective scenario that is given as a question to you. Okay, you have to draw in this manner. Okay, correctly you have to understood, and you have to fill all this information and draw the diagram. That is a timeline diagram. Now, so along with the ARC, as I have already told, every ARC should have the receive window. Every ARC, the receive window must be sent. Can anybody tell me what should be the receive window? So that is going to send. So from the sender to receiver.
So size of
one is a receive window. If you understood correctly, please tell me. So this is at the receive window, receiver end also. So there is a receiver window. Let's say this is the receive window, and also another window is going to maintain, that is called as a send window. So both the end maintains two window. So one is a send window, one is a receive window. Now receiver has advertised its window as 800. So can anybody tell me? So based on this, what the sender is going to do? Based on this, what the sender is going to do? अभी flow control के बारे में समझे. So can anybody tell me, by receiving the receive window size, what the sender is going to do? Sender क्या करेगा?
It will adjust its window according to the receive window.
Which window, Hitesh?
Of the receiver.
Which window, Hitesh?
the sender window.
Very nice. That means so now receive window is 800. That is being advertised in the ARC of the second packet. So based on this, the sender is going to adjust its send window. So that means now the send window size at the sender is 800. Try to understood. Very, very important concept. Now So when it is going to advertise the receive window, sender is going to receive it, advertise its receive window. Let's say the receive window size at the so sender is 1000. The receive window at the sender is 1000. So it is going to advertise the receive window. What should be the value it is going to put? 1000. So that means receiver window is being advertised. So by the sender means it is going to advertise its receiving window. Okay. Once its receiving window is advertised, what the receiver is going to do? What the receiver is getting? There are two windows at the sender and receiver. Every end must maintain two window. One is a send window, one is a receive window. Okay. What is a send window? Send window says, so whenever application layer is generating some message, so whenever the packet is coming to the transport layer, send window is being maintained at the transport layer. So transport layer should keep the packet in the send window. Okay. So when the application layer is generating a packet and sending it to the other end, so the transport layer of the sender end must keep those packets in the send window. Okay. So then what is the receive window? Receive window is, so whenever a packet is being received, so at the sender side from the receiver, so then it is going to come and put in the receiver window. Receiver window is meant for keeping the received packet, and send window is meant for keeping the send packets. So then next question, how the send window and receive window are going to set? Receive window is always based on my capability. What is the receive window of receiver? It depends on my capability. Let's say my capability is 800. So I say receive window is 800. Similarly, my capability at the sender end is 1000. So that's why, so my receive window is 1000. But how the sender window is going to set? Window is going to set based on the receiving window capability of the other end. That means if the receiving window capability of receiver is 800, then the sender is going to set its send window as 800. So similarly here, as the receiving window of the sender is 1000, so sender window at the receiving end must be 1000. This is how the sender and receiver window are linked to each other, and that information must be sent in every ARC message. This is the feedback mechanism I told. There is a feedback mechanism. So between the transport layer of the sender and receiver to know each other capability. And this is what is being done in every ARC packet that is being sent from one end to the other end. Everybody understood up to this point? Up to this point, everybody understood, or anybody
Yes,
has any? Let's say. So talk about the send window. Now this is my send window at the sender. Okay. Starting sequence number is 100. So I'm putting 100. Then 101. Okay. So dot. Okay. Now can anybody tell me? So when I go and send the packet of data, so now I am sending data of 200 bytes. So what should be the sequence number? Data. So no. So packet loss is going to happen. So that means in order to make a synchronization between the sender and receiver as far as the flow control mechanism is concerned, the send window size must be set based on the receive window size of the receiver. Send window size must be set based on the receive window size of the other end. Okay, so that's why this is the how the receiver window and sequence number. 300 is the last sequence number I have sent. So then if I have already sent, so from 101 till 300, what is the next packet I can send? We understood. As far as sending of this packet is concerned, so my SF pointer remains at 101 and my RN pointer remains at 301. This we have already explained in the previous class. So left wall of the window now remains at 101 because that is the first outstanding packet at this point of time. So where SF is pointing to, and I have sent 200 bytes of data. So that's why I have sent up to 300. So now if I at all want to send the next packet, then the sequence number of the next packet should be 301. So where RN pointer is pointing to now, so based on the window size, now my window size is 800 at the send window. So that's why it start at 101 means the last sequence number which is falling within this window is 900. Okay, so this is my current window as far as sending of the data is concerned. Now after this, what happens? So now I receive an ARC. 301. Okay, let's look into the window at the receiver. What happens at the receiver? Receiver के पास अभी, tell me. Okay, so RN pointer कहाँ होगा? So this is 100. This is 101. So dot. Let's say this is 900. 901. Okay. What is the meaning of it? What is the meaning of sending an ARC of 101? That is, I'm expecting a packet with a sequence number of 101. So that's why my RN pointer is 101. Is it understood or not? While I'm receiving this data, okay, or before receiving the data, whatever you say. So my Rn pointer is pointing to 101 because so prior to this I have already sent an arc of 101. What is the meaning of it? So that means I'm expecting a packet with a sequence number of 101 from the other end. So that's why now my Rn pointer should point to 101. And when I receive this data, actually, now I got the data with a sequence number of 101. That's why it is a valid data. Ends with 900 because the size of the buffer is 800 bytes. So that's why my Rn is pointing to 101 and the buffer is so 900. I mean, the buffer is of 800 bytes. So my write wall of the window stay at 900. This is my receiving window. This is my receive window. This is my send window. Try to understand. Okay, this is my receive window at the receiver and this is my send window at the sender. Now, after this 301 is sent. So when 301 is sent, what happens? Can anybody tell me? Now look into the receiver window. Receiver window को देखिए. जब so मेरा when I receive 200 bytes of data, okay. So and I generate a 300 arc of 301 to 301. My Rn pointer is going to move to 301. So when Rn pointer moves from 101 to 301, what does it mean? The left wall of the window moves towards right. So if I receive some more amount of data, what I'm expecting at this moment? So that means Rn pointer is pointing to 101. That means I'm expecting a packet with the sequence number of 101. And I'm also receiving a packet of sequence number 101. Then only, so my Rn pointer can move. Then only I say it is a closing operation. So operation is closing at the receiving end. At the receiving side, the window closes. So when I receive some more amount of data with what I'm expecting, so then only I'm going to so close the window. I have advertised my window size is 800. And as I so receive some amount of data, what I'm expecting as a consequence of it, my window closes and now my window is reduced to 600. So that's why what I should do. So I should advertise the window size, receive window size in the acknowledgement. So what should be the value? Right, understood? Are you getting my point? So now in this arc, I will send an so sequence for the arc number of 301 and I again advertise my receiving window as 600 because now it is no more 800. I don't have any 800 bytes of buffer available. I have only 600 bytes of buffer is available to accommodate so the sender data. So this is the new receive window is being going to be advertised to the other end. So that's why new receive window is 6000. Is this understood? 600. Why the receive window moving to 301? So that means so left wall of the window is moving towards right, and that is nothing but closing operation. And why it is happening? Because I receive an arc. That means when the sender is receiving an arc on behalf of the data it has sent, at that point of time, the window is going to close. So that's why that is so another scenario when the window is closing as far as the sender is concerned. Now what happens to the so look into here. So now so what I'm saying currently the receiver has advertised the window size to 600. So I have to again reduce my window size to 600. Sender has to adjust according to the size of the so receiver. Okay. So that's why now so as it is 600, so it starts from 301. It has to obviously go by 900. That means the last sequence number of this window should be 900. So that's why I can maintain the so send window as 900. So that's why SF is here, SN is here, and my window is ends with 900. Now next scenario. So now I send another 300 bytes of data. After sending another 300 bytes of data, where is my SN? So now my next packet I can go and send is 601. So my SN pointer is pointing to 601. So that means now the sequence number of the packet. What should be the sequence number of the packet? I'm going. So it starts at 101. Okay. So then my current window starts at 301. Okay. And it is now here is my current window. Okay. Left wall of the window is here. After receiving this 301 with 300 bytes, can anybody tell me at this moment, let's say 100 bytes of data is read. Okay, let's try to understood 100 bytes of data is consumed by the application layer. 100 byte का data consume कर दिया application layer. अगर application layer has consumed the first 100 bytes of data, so will it be required to store in the buffer any window size reduce हो गया 300 को 600 before receiving this 300 bytes 600 originally it was. Now I receive 300 bytes of data. It has reduced to 300. Again, after that, I'm saying 100 bytes of data is consumed by the application layer. So 100 bytes of buffer is free. If 100 bytes of buffer is free, now 100 bytes of more. So I mean, free plus available. So my window size becomes 400. Try to understand this. Now my new window size becomes 400. If it is 400, what will be the right SF pointer? Where is my SN pointer? SF pointer कहाँ पर होगा?
601.
Yes. So 300 में पहले था, 301 में था. I receive an arc of 601. So that means my SF pointer moves to from 301. My SF pointer moves to 601. Okay, that means window is closing. Window is closing. This is a close operation. Window is closing. Okay. So now after this, what will be the right wall of the window? Left wall of the window means if it is 400, so right wall of the window must be at 1000. So that's why this is my new window. Okay. So last point to be discussed for today's class. So now at this point of time, I don't have any more data to send. मेरा SF pointer यहाँ पर है. So where will be my SN pointer? SN pointer भी यहीं पर है because I am not sending any more data. Okay, and this is the right wall of the window. At this point of time, I receive an arc. Can anybody tell me what is the chance of receiving an arc? Is it valid or invalid? मैं send data नहीं कर रहा हूँ. So sender कुछ data send नहीं कर रहा है. But I am saying the receiver is sending back an arc. Is it possible? Yes, it is possible. What is the scenario? Let's say what happens at this point of time. So still, how many bytes of data to be read by the application layer? अभी कितना bytes का data still pending in the buffer to read data is consumed by another 200 bytes of data consumed by the application layer. Sender को send नहीं किए, but application layer of the receiver has consumed another 200 bytes of data. In that circumstances, what is going to happen? Can anybody think of? So now my current window is, so RN is pointing to 601. Okay, and I have already buffer 400 bytes of buffer. 400 bytes of buffer already occupied by the received data. So my RN pointer is pointing to 601, and this is the left wall of the window, and right wall of the window is at 1000. This is the scenario. So now what happens? 200 bytes of data is consumed out of 400 bytes of data. So 200 bytes of data is consumed. 200 bytes. So now right wall of the window is going to move towards right. This is called as the open operation. And so that's why now my new right wall of the window is 1200. This is my new window. This is my new window. Okay. So now if it is, what is the window size? What one? I have still sent arc of 601. And what should be my receive window?